All right, so let's figure out how to use a matrix, an augmented matrix, to solve a system of equations. And I hope you see that this is actually kind of fun. You got to think of it kind of like a game. So we know that in the previous video I explained sort of the general idea and what the rules are for simplifying a matrix. So let's actually look at an example. The first step is to actually write this as a matrix. So as an augmented matrix, this would be 3, 6, 12, and 2, -5, -1. And remember, we're going to put that little dotted line right here to represent that these are the answers over here. Okie dokie. So here's the first goal. Goal number 1 is to turn this number into a 1. That's the first step we want to do. So if it's already a 1, you're good to go and you can go straight to the next section. If it's not a 1, we need to figure out how to make it a 1. So there's two things we can do. You can either divide the top row by this number, because if I divided the top row by 3, I'll get a 1 here. Or you can use another row. So like for example, if I multiplied this row by -1 and then added it up, if I multiplied again this row by -1, I'd get a -2, and then added it up, I'd get -2 plus 3, which would become a 1. Okay? That's a little bit more complicated, so let's just divide the top row by 3. And so here's what I want you to write. Row 1 is equal to row 1 divided by 3. So R sub 1 means row 1, and we're replacing row 1 with row 1 divided by 3. So that will give me 1, 2, 4, and the bottom row didn't change. Okay? So we're always going to do operations to rows. So we did row 1 equals row 1 over 3, and I highly, highly, highly recommend you write this to kind of keep yourself on track of what you're doing. Once this number is a 1, the next goal is to make everything below it a 0. Okay? So we see that here's a 1. This is not a 1, so we need to make it a 0. And the only way we're going to be able to do that is by adding this row to this row. So because this is a 1, all I need to do is multiply it by -2 and then add that down. Okay? So here's how to write this. We are replacing row 2, so you write row 2 equals. And it is going to be equal to row 2 plus -2 times row 1. Okay, let's walk through that again. We're going to replace row 2 by adding it to row 1 multiplied by -2. So here's what it's going to look like when we're done with that. First off, we're only replacing row 2. So row 1 is not going to change. Okay, row 1's not going to change. Now, row 2, again, this is what you're going to end up with, and so just follow what you're doing here. It's equal to itself plus -2 times this number. So -2 times 1 is -2, plus 2 is 0. That's what we wanted. I know that's kind of tricky, but you'll get it with practice. Let's do the next one. -2 times this number plus this number. -2 times 2 is -4. -4 plus -5 is -9. Okay? And the last one, -2 times 4 is -8, plus -1 is -9. Again, it's take -2, times it by the top row, and then just add what that is to the bottom row. So -2 times 1 was -2, plus 2 is 0. -2 times 2 is -4. -4 plus -5 is -9. -2 times 4 is -8. Plus -1 is -9. Okay, we can actually stop here. The next thing you'd want to do is make this number right here be a 1, but you can kind of skip this next step. Let me show you. We want to turn this into a 1, and so we would do that by dividing row 2 by -9. So divide row 2 by -9, and that becomes the new row 2. So we didn't change the top row, so that just stays the same, 1, 2, 4. But now the bottom row would be 0, divide by negative 9, divide by negative 9, which means 1y equals 1, or y equals 1. Awesome, we just figured out what y is. Now, the reason I said you kind of could skip that step is because if you just wrote this line as an equation, notice we have no x's, so it would be just negative 9y equals negative 9. Divide both sides by negative 9. Either way, you get the same thing. And notice that dividing both sides by negative 9 is basically what we did to go from here to here. So it's basically the same step. It's just, do you want to do this last step in the matrix, or do you want to just go straight from here and solve? Me personally, I kind of just go straight from here to this line once we have no x, and then just solve. But it's up to you. Now that we know what y is, we can go to any row. You can either go back to the original equations if you want, or you can use any row to solve for, except for this row, obviously, because we don't have x, or this row. So let's use this row right here. It's 1x plus 2y equals 4. That's this row. And we know what y is. Y is 1. So x plus 2 equals 4, minus 2 minus 2, x equals 2. So the answer is 2, 1. Now, I know that felt like it used a lot more brain power than using substitution or elimination, but I promise you that with practice, you will get the hang of this. Let's do the next one. It's going to be, first, write it as an augmented matrix. 5, 15, 20, 2, negative 4, 3. Okay? The strategy is still the same. It's going to be, first we need to get a 1 right here in the top left corner. I notice I could either do negative 2 times this row and add it up. That would give me a 1 here because it'd be negative 4 plus 5. But it'd be easier if we just divided by 5. If this would have resulted in fractions, dividing by 5, if that would have resulted in fractions, I would have multiplied this by negative 2 and added it up. But since we don't get any fractions, let's just divide the top row by 5. So row 1 equals row 1 divided by 5. We're replacing row 1 with row 1 divided by 5, which gives me 1, 3, 4. And on the bottom, we have 2, negative 4, 3. Okay, now that this is a 1, we want everything below it to be a 0. So we need to make this 2 a 0, and so the whole point of making this a 1 is to make this next step easier. Row 2, we are going to replace with row 2 added to negative 2 times row 1, because that'll make this a 0. So I encourage you to write row 1 again, because we're not changing it. So let's just write it down and get it out of the way. Now, row 2 equals itself plus negative 2 times row 1. So negative 2 times this is negative 2 plus 2 is 0. Negative 2 times 3 is negative 6, plus negative 4 is negative 10. Negative 2 times 4 is negative 8, plus 3 is negative 5. And now that we've done that, we're actually just ready to go straight to finding out what y is. We don't have an x, but I do have negative 10y equals negative 5. Divide both sides by negative 10. Y equals negative 5 over negative 10, which is positive a half. Okay? Now I know what y is equal to, so let's substitute it back into an equation to find x. I'm going to use this equation to find x. And the reason is because, do you see how y is a fraction? It's a half. If I use this equation, the 4 is going to cancel the fraction. So that'll be nice. I just don't like working with fractions. So 2x minus 4 times a half equals 3. So negative 4 times a half of 4 is 2. A half of negative 4 is negative 2. Add the 2 over. And then divide by 2. So the answer is 5 over 2, a half. And as always, you can check your answer by just plugging in these two values for x and y into both equations and seeing if they work. So in terms of a 2 by 2 equation, it's about the same amount of work as doing substitution or elimination. But where this is really going to be useful is in a 3 by 3 equation or bigger. And so I hope you like the matrix method. We now have three ways of solving an equation: substitution, elimination, or using an augmented matrix. So I hope you like this. I hope it's making sense. I really enjoy this process. Again, to me, it's kind of like a game. And that's to have a good attitude about this. That's how you should treat it as well. In the next video, let's see how to use this to solve a 3 by 3 system. And I will see you in the next video.